All right, so rates of change is what this lesson is about. It's the second lesson. All right, a rate of change, we've always, okay, in Algebra 1 and Algebra 2, we were bad about saying the average rate of change was just a slope. And we get that from the fact that the first function we ever learn about is a linear function. And a linear function has a constant rate of change, and we call that slope. And the slope formula was y2 minus y1 over x2 minus x1. The average rate of change is still that same formula, except for now we don't have a constant rate of change on most of our functions. So when we're looking at our functions, we call it average rate of change because it's not linear anymore. It's a curvy graph. And the rate of change changes as we move across the graph. A positive rate of change indicates that a function has a positive slope. A negative rate of change, this should say the function is increasing. That's what I noticed is there's a typo there. A negative rate of change indicates that a function is negative slope and the function is decreasing. So this should say increasing. And sorry about that, I did not see it until I did the video, but there's a typo there. All right, think about it like a roller coaster. So here we are doing this. And so as we go up, we have a positive rate of change, and as we go down, it has a negative rate of change. At the instant point, when you're at the top peak, or at the bottom of a valley, like right here would be the bottom of the valley, you are not moving up or down. At the single instant point, you are changing between going up and going down. At these points, the rate of change is neither positive or negative, and the rate of change is 0. So at T1, we have a positive rate of change. At T2 is 0, and T3 is going down, so we have a negative rate of change. All right, so looking at this one, this says to arrange our rates of change at the 3 labeled points from least to greatest. So if you draw yourself little lines, little secant lines, to the graph at these points, you can better see the slopes. So which one, if I'm doing least to greatest, which one is negative? Well, that's B, so it's going to be the smallest. Which one is 0? That's C. And then this one is going up and it's the greatest, A. Where is the average rate of change the greatest? Again, I took f of negative 3, so at negative 3, I drew myself a little line. F of negative 1, I drew another one. And at f of 0 right here, I did another one. And which one's the greatest? Well, the one that's going up, so f of 0. This figure, again, is another figure. Which rate of change of G is the least? So, again, we drew our little lines and looked at them. Now look, this time we have 2 that are going down. So, but which one is the steepest? D is the steepest, so it will have the least rate of change. It will be the most negative. Okay, we will be doing average rate of change throughout AP Calculus. Every time we turn around and we look at a different function, average rate of change is going to be there. And so I'm just going to move on off of this slide. That's pretty much what this slide says. All right, now on this one, it says which interval is the average rate of change the greatest. So I took and I labeled each interval. So from 2, which is less than or equal to x, is less than or equal to 3. So I went from 2 to 3. Here's 2, here's 3. I drew that line. Then 3 to 5, I drew that line. Here's 3, here's 5, and you see this line. Then 5 to 7, so from 5 to 7, and then from 7 to 8. So which one's the greatest? Well, only one has a positive slope, so it's C. Now, this example is in here purely so that you know how the AP board the College Board wants you to write any free response question that you get. They do not just want you to write y2 minus y1 over x2. They don't want to just see this. That's pretty much what we have done up until we get to AP Pre-Cal. Proper mathematics notation is to say the function f, or whatever your graph is called. If your function's f of x, you use f. If your function is g of x, you use g. If your function says m of x, you use m of. So whatever your function is labeled, that's what you would use. So we're going to do y2 minus y1 over x2 minus x1. We are doing that. However, we have to write it properly. So f of 2. Here is f of 2. This is the 0.25. And then -4. That is the point -4, 0. So what I will write is f of 2 minus f of -4, because this is x1, y1. x1, x2. Because they're giving it to you in intervals. So f of 2 minus f of -4 over the x values, which is 2 minus -4. Okay? So then I plug in the y values for f of 2. F of 2 is 5. And the y value for f of -4 is 0. So 5 minus 0 is 5. And then I went ahead and changed this minus -4 because I don't like looking at it like that. Because that means 2 plus 4 is 6. So 5 over 6 is the answer. And then I did another problem just for good measure to be sure that you could see it. So we did another one. And so at -3, here is -3. We have the point -3, 0. And then at 4, this is the point 4, -8. So same thing, f of 4 minus f of -3 over 4 minus -3. So at f of 4, it is -8. At f of -3, y is 0. So 8 minus 0 over 7, because 4 minus -3 is 4 plus 3 is 7. And this is our answer. All right, looking at this one, this is all words. And I had to draw pictures. That's why you see pictures everywhere. The graph of f of x in the xy plane has a negative rate of change. They're telling you that you are looking for a negative rate of change. Which of the following definitions for the variables of x and y would best model the function? The age in years of a child, that's x, and y is the height in inches. So as a child grows older, they grow taller. So that's going up. So that's not going to give us a negative rate of change. Letter B says the total number of points scored in a basketball game versus the time remaining. So here's the points, here's the time. At the beginning of the game, you've got all the time left. As the game progresses, the time goes down, but the points are hopefully going up if you're doing your job. So the points are going higher, but the time is going down. So this one has a negative rate of change, and it's our answer. But just to be sure, we always look at all the choices. Letter C says the time in seconds since a ball was thrown up in the air versus the height in feet of the ball. So here's the time. Here's the ball. If you throw a ball, you know that a ball goes up and goes down as time progresses. So that one's a quadratic function. And the radius in meters of a circle versus the area. The bigger the radius is, the bigger the area. So that one's positive. All right, this requires us to use our graphing calculator. So I'm going to go through the graphing calculator, and I've got my paper here because I won't remember what to type in if I'm not looking at something. So we're gonna go and we're gonna type this function in. Oh, look, I didn't want to do that. Okay, sorry. Just saw something I didn't realize it would do until now. Anyway, let's type in our function 3.16 plus 4.2x minus, all right, be sure to use a minus sign for a minus sign. And if you have a negative in, like when I put in -10 in a little bit, you can't use a minus for that on the graphing calculator. You must use the negative sign. All right, so minus 0.85x squared. Okay, graph. There's the graph. Now, what I want to do is I want to find the rate of change over the interval from -10 to 8.348. So what I'm going to do is I'm going to go second quit to come out of this, and then I'm going to go vars. And remember, this is on your notes. This is on your notes. The steps are on the next slide. So vars, y vars, I'm going to hit function, and I'm going to tell it that I want y1. So I'm going to hit that. Then I'm going to put in parentheses, and I'm going to put my y2. I'm going to put 8.348 in first. I'm going to close that off. Then I'm going to hit minus, because I'm doing my y2 minus y1. Minus, and I'm going to do vars, y vars again. So vars, y vars, function, and I want that function there. And I'm going to put in -10. Do not put -10. It won't do it. All right, now I'm fixing to get that answer. All right, that is giving me the y values, the difference in the y values from this interval. Then I'm going to divide that answer. There's no need in typing that answer in. Just hit divide, and the calculator knows that the answer is there. And I'm going to divide by 8.348. You want to make sure you go in the same order right here. So 8.348 minus -10. Close it off. That lets the calculator know that you are dividing by that entire thing and not just by the 8.348. And that just gave me the average rate of change over that interval. So the average rate of change over that interval is 5.6042. And I thought it would do that, and it did. The calculator went away. Okay. So now I'm going to do the same thing, but I'm going to do it over this interval here. So I'm going to go vars, y vars, 1. I'm going to hit 1 again. And this time I'm doing it over the second interval. So 5.605. Close it off. Minus vars, y vars. Hit that again. And I'm going to put in -0.663. I'm sorry, they are cutting grass outside my window. Which that's a good thing that they're cutting grass, but you know. All right, now we're going to divide that answer by 5.605 minus -0.663. And that average rate of change, okay, when you see this, this is in scientific notation. So what it is telling me is that is -7 times 10 to the -4th power, which is practically 0, but it's 0.0007, and it's negative. Now, I'm not going to do each and every one of these because it's going to make the video too long, but you see what we're doing, and it says, which of the following is correct? All right. This one says it has a positive rate of change. Over this interval here. I had to have done something wrong. And letter B says that it has a positive rate of change. That's not positive. Letter C says that it has a negative rate of change. And letter D is the correct answer. So I'm going to look back at A and just make sure I type that in correctly because I obviously did not. So I'm going to look back at the thing and we're just going to do it again. First of all, we'll make sure I type the whole thing in right. 3.16 plus 4.2x minus 0.85x squared. I did. Okay. And we're going to do that first one again because something went awry. Y bars. 1, 1. Okay. 8.348 minus bars, y bars, negative 10 equals, divided by, I wonder if there's a typo on with his work, 8.348 minus negative 10. Okay. We will move on and I will look at that because letter A, it says a positive rate of change and it does have a positive rate of change there. So it really does. I even looking at the graph, it does. And even looking at his notes, it does. 2.4. And this is correct. I think there's two answers on this one. I think it's A and D. So looking at his graph, if you can see what I mean, looking at his graph, it's definitely got a positive rate of change from negative 10 to 8. So anyway, I will take a look at that later. All right, there's our directions. Let's do this. All right, and this one, the table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? All right, y'all, you can do average rate of change over each one of these if you want to, and that is fine, and I will do the first one just to show you. So the first one is from 1800 to 1850, so you're looking at these two. So doing this letter A, you would do 46.1 minus 41.24 over 1850 minus 1800. And you would get that average rate of change, which is 0.0972. But I'm going to tell you that you can logically look at this. If I look from 1850 to 1900, look at this. This is an increase of about 5-ish. This is an increase of about 7 or 8. This is an increase of about 17. And this is an increase of about 11 or 12. So you can find your answer just by looking at the table, his letter C. Or you can find the average rate of change for each one of those intervals. It doesn't matter how you do it to get the correct answer. Thank you.